Hey everybody, my name is Chris and I'm a tutor here at Chegg.com. I mostly do math and a little bit of computer science, and in this video we're going to do an example with the angle of depression. So here, a 6-foot tall man is standing on a cliff and he spots a boat on the water below, and the angle of depression to the boat is 67 degrees, and if the boat is 500 feet from the base of the cliff, then how high is the cliff? So with problems like this, it's always important to draw a picture so that we can see exactly what's happening. So here's our guy standing on top of a cliff, and our guy is 6 feet tall. And the cliff, we don't know how tall it is, that's what we want to find out, so let's go ahead and just call that H. And there's a boat 500 feet from the base of the cliff. So here's our little boat, and the guy spots the boat with an angle of depression that's 67 degrees. So we want to be very careful about what the angle of depression actually is. So we might be tempted to say the angle of depression is this angle in here, because that completes, that sort of fills in the right triangle here. But we don't want to do that. That's not actually correct. What's correct is that this angle up here is actually the angle of depression. So what we have is 67 degrees over here. So the angle of depression is actually the same thing as the angle of elevation as measured from the boat. So that's an important thing to keep in mind, is that really the angle of depression and angle of elevation are pretty much the same thing. So this is 67 degrees, this here is H, that's 6, and remember the boat was 500 feet away. So we'll label this 500. And we can safely assume that this angle here is a right angle. The cliff and the water make a right angle. So we want to find H. How can we do that? Well, remember that property from geometry that says if we have two parallel lines that are cut by another line, then the alternate angles here are going to be the same. So these two lines are parallel. So since this is 67 degrees, then this angle here is also 67 degrees. And again, that's the angle of elevation. So that's kind of why they're the same, is because of the parallel lines. So now let's just focus on this right here. So what we have right here is a right triangle. And let's go ahead and draw that out separately. So we have a right triangle. This is 500. Here's our right angle. This is 67 degrees. And this entire thing together is H plus 6. Okay, because the cliff has height H and the guy is 6 feet tall. So the whole thing altogether is H plus 6. So what do we know that relates this angle over here to the side that's opposite that angle and the side that's adjacent to that angle? That's going to be the tangent function. So what we know then is that tangent of 67 degrees equals H plus 6 divided by 500. The tangent is the opposite over the adjacent. All right, and we want to solve for H, so let's go ahead and go to the next page. We have tangent 67 degrees equals H plus 6 over 500. Multiply both sides by 500. And we have 500 tangent of 67 degrees equals H plus 6. And then subtract 6 from both sides. And that's going to give us our H. Okay, now we're going to have to toss this into a calculator because 67 degrees is not a nice angle. So let's see if we can pull up a calculator. And we want to find the tangent of 67 degrees. So make sure our calculator is in degrees. And then we have 67. We want the tangent of that. And then we're going to multiply that by 500. And then finally we subtract 6. And when we do that, we get 1171.926 approximately. So H is about 1171.926 feet. Okay, and we weren't told really how many decimal places to round out, so 3 is fine. So about 1171.926 feet is the approximate height of the cliff. So this has been an example involving the angle of depression, and I hope you found this video helpful, and thank you for watching.